has?
Don't know.
Oh, that means maybe a long time later.
No, no. Could be next week. Who knows?
What?
Good job. So you got them right. Good job, Ben. Let's continue. We're on. Yeah. Okay. Big title if you can write that down. Actually, I was thinking last night, I can't remember if I showed you this. Can you go back to the lesson on where we did equipotential in your notes? No, your notes. Notes. Good. No, I did show you these. Did that one, we did that one, and we did, okay. No, I just checked. I couldn't remember if I did that one, but I did, so it's okay. Alright, we'll continue. You got that? Yes? Now, can you see the picture there? We've got a magnet and we've got a current. And we remember we can use our left hand and we can find the forces up. Remember this. You have your beautiful picture there from last week. Yeah. So you might want to know what's the story if we have a current instead of a charge. So anyways, let's have a look here. So I'll explain now. Do you remember the formula? If there's a Q moving this way, and let's say there's a B this way, and then you get a force. Do you remember what the formula is?
Q.
Yes?
QV?
Yes?
Or
No?
B?
Yes.
Oh.
No. But instead, let's say we have a current. Okay? Well, you know that Q equals IT. So you can get F equals QIVTB. Well, what's VT? Oh, sorry, no Q here, sorry. Thank you. What's VT?
We do the S.
Yeah. So that's BIL, where L is the length.
Oh.
You seen this before? So, what I'm trying to say is, actually I didn't have it in a box. If you have a current instead of a charge, this is the formula instead of this. And it's quite easy to prove. Okay? Write that down. Yeah. Yeah. In this formula, okay, we know this. Okay. So here, oh sorry, can you see? This and this are, yeah, perpendicular. So what about if we have this? There's B, there's I, but they're not perpendicular. There's a theta here.
16.
What is it? Do you know what I mean? They're not perpendicular.
Yeah.
It's at an angle. Any ideas what to do?
Just like
Yeah.
the furniture. Like the
Yeah, what's this called? Guys, what's this called?
cosine.
Yeah, no, but what's the verb?
Sorry.
Verb.
Yeah, the
What?
furniture or
Verb.
foundation. But I forget what's the
Anyone know the verb?
no yes no this
Resolve.
resolve.
Oh. Yeah. Yeah.
You remember this verb now?
Yeah.
So which one do we care about? The cos or the sine?
Sine.
Yeah, because it's perpendicular.
So it is your sine.
Just use sine, yeah, because you need the perpendicular one. So you got this formula. Mm-hmm. Okay, another formula. Write this down. Oh, so I don't forget, Sylvia needs to see you after this class. So after the 2 classes. Okay, got that? You wrote that down? Okay. So we got this one. Now, if a force acts on a current in a magnetic field, then could we use this force to do work? Yes, we can. So what we mean is, if we have a current and we have a magnet, we can make a force. Could we use this force to do something for us? We can. This here is called the DC motor. The way it works is quite simple. It's really simple. The current moves along this armature, and you notice if you look here, for example, if I use my left hand, B is left, I is in, so F is up. And here, B is left, I is B is left, I is down. B is left, I is out, so F is down. Okay? So you get a force going up here and a force going up here. So what will happen to this? It'll turn. Yeah?
No chance.
Huh? Say again?
No chance.
It'll turn.
The current is.
Now the current.
No chance because the current and the V is this like this.
Huh? No change? What do you mean?
Don't move. This
No, no,
part.
no.
This part.
No, no,
has
this-
force.
Now this force goes up,
Yeah.
this force goes down, so this will turn.
Oh, the turn is this one.
Yeah.
I thought you said the
Armature.
armature. Yeah.
The armature will turn.
Yeah.
Yeah.
This part. This part.
This part?
Yeah.
Yeah, this part will turn.
Yeah.
Because it's one piece.
Yeah.
So what you could do is you can connect this to a wheel. Make a wheel turn.
What's wheel?
Sometimes you make me so sad. Wheel.
Oh, yeah.
You know this?
Yeah, I know this.
Okay, good. So, you can make a wheel turn. This is how, you know, electric cars, Lewis, this is how they work.
Yeah,
Yeah.
for
Toys, yeah. Now, this piece here is important because you see here, they're not connected. It's kind of like, it's not like this, it's like this. They're not connected. And the reason is we want the current to go up and down. We don't want the current to just go across. Okay. Also, this here is a brush, like something soft like this. And the reason for it is so that, well, obviously, if it was a wire like this, what would happen? Well, then when it turns, it would get stuck. So it's actually it's a brush. You know this, yeah. This is called a it's made out of carbon. This is called the commuter segment, this piece here. This is the carbon brush. North and south, this is the armature. And I'm sorry, but you need to draw this. Yeah. Yeah, you have to draw it. I'm sorry. Make sure you have its name. What's its name, Summer?
Do you see more model?
Yeah. And make sure you get all the names, okay? You need all the names. What?
what is the armature?
Armature.
What was it?
That's an armature.
What was meaning?
It's just a noun. It's a noun.
Now?
Noun. You know noun.
I don't know.
Ah, you do.
Means
Oh.
N-
What is?
This is an armature.
Oh, this circle.
This this thing is an armature.
Okay.
kind of hard to explain then what an armature is, but another example of an armature is, you see on the top of the door, the part that goes like this, on the top. You see there somewhere?
Oh.
On the top of the door? The part that bends like this is an armature. It's kind of like arm, you know, so.
Oh, I know.
Yeah? Okay. Right. Next. Oh yeah, let's calculate the torque.
What is talk?
You did this in mechanics. Torque is turn-in force.
Oh, it's 10. Oh, it's 10.
Huh?
I mean, it's
Tau.
tau is 10. It's 5 tau. Something.
Ah. What? No, it's the same letter, different meaning. We also use this letter, L. It's this. Force multiplied distance. Now the force here, we know the formula. It's BIL times distance. Now, look at this part, LD. Well, this is the L, and this is the D. Oh, by the way, sorry, it's actually, to be clearer, it's FD because it's a couple. BILD. So this is L and this is D. Do you remember couple?
FD.
Yeah.
L equal FD is some.
Yeah. Yeah, when there's two.
Oh,
Remember this?
yeah.
And we called it a couple.
Okay.
Yeah? But LD is area. This is area.
LD is
Yeah, areas. L, D.
Yeah.
Okay? Now what you can also do, you see here in the armature, you can actually have it wrapped around maybe once or twice. You don't need to have only one. You could have like maybe, you know, 2 or 3 armatures, the wires. So what you can maybe have is n of them. So I like to remember it like this. Turn-in force equals IBAN, like the bank. You know IBAN?
No.
You don't know IBAN?
What's IBAN?
Is when you transfer money at the bank, you need to know the IBAN.
Oh,
Is
yeah,
the-
yeah, yeah.
Yeah, you know IBAN. Is the number for the bank account. You know
I
IBAN?
asked you the
yeah,
question.
Yeah, I know this.
You know this, okay. The reason you need to remember this is because this is not in the formula book. This one's not. So it's good if you can remember it.
What's it?
Huh?
Um,
What is N?
yeah.
How many? Is
How many armature turns?
Oh,
So like, you know, if you have your wire, maybe you can go 1, 2, 3. So then it's 3. You don't transfer money, Ben?
I don't.
No?
I don't. Oh, I mean, I never go to bank and use this.
Okay.
Only.
Western Union? You go to the bank and do this. You know
because-
IBAN.
Yeah, because when I first account,
Yeah.
I don't have the card.
Ah,
I need to make some cash. So I need this.
Yeah.
But no, I can use
the
use
card.
the phone,
Oh,
the
good.
app.
For transfer?
Yeah, yeah,
Oh,
yeah.
good. Transfer with China?
China or
Mm.
Ireland card.
Cool. No, you could do that. That's good. Okay, next. There you go, Ivan. Now, remember that flux is the number of magnetic field lines. However, imagine now that the field passes through n identical regions. Let us find a formula for it. So it's just going to be NBA, yeah. So like, I'll give you an example, okay? Here, we call this area A. Let's say there's one flux line here. So we would say the flux is 1 Weber, okay? But let's say we have another area behind it, and another one behind that. And we want to look at this total area. Then we say the flux is 3 Webers. Okay. So the total flux would equal how many you have, which is n, times the flux for one of them. But this is the same for all of them. And also we have the formula that B equals flux over area. So we can just change this into what we saw MBA, like that. Now we don't call this total. We have a special name for it. We call it the flux linkage. Now let me just see if I have it here. Yeah, no, actually maybe this is better to write down.
With A.
The area of 1.
They will the same area.
This should be the same for this formula. Yeah? Now, let's say it makes an angle theta. So here, instead of being 90 degrees, we say there's an angle theta here. Okay? So yeah, you have cos and you have sine. Which one would you need? Yeah, so the only difference if there's an angle is that there's a cos theta here. That's all. Yeah? Got that? Got that? Okay. The total flux is also called the flux linkage. Did you write that name down? Yeah. Okay. Right, let's have a look at some questions. So you have a copper wire with 2 amps, and the copper runs through a magnetic field, and it's 20 centimeters long, and the flux density is 3 Tesla. What formula do I use to calculate the force? BIL. And for the second one, if the angle is 80 degrees?
BIL sine 30.
Sine 80. 80.
Oh, 80.
80. Okay, calculate. Give me the 2 answers.
BIL.
Yeah. Get out your calculator. Ben.
6 times 2.
Okay, but what about for sine 80?
It's 1.2.
Yeah.
18 just 1.2 times sine.
You don't know what sine 80 is. You need your calculator. I'm sorry.
Oh, calculator. Where is my calculator?
No. Are you in degree mode? Degree?
Oh, it's R.
Yeah.
Why
This one.
Sine 80, isn't
Oh,
it?
sorry.
is degree?
This one.
Yeah.
3 is okay.
Beautiful.
1.18.
That's what he got too.
Yeah.
Okay, good job. Right, next. A DC motor is used to turn a wheel. You've got a current of 3 amps, flux density of 5 Tesla, 1,000 turns. So the wire goes around 1,000 times. And it's a square of length 20. What's the torque? The turning force. Right, so what formula is this one? IBAN. Okay, so off you calculate.
Three solid.
What's the unit?
Newton. It's not a force?
You forgot something.
What's that thing?
What answer did you get? What was your answer, Summer?
Three solid.
3,000 Newton meters.
Oh, meter.
So
One.
the N is 1,000.
Yeah.
So what do you get?
He said 3,000.
Three solid.
Oh.
Yeah. Continue?
The square of length.
Yeah.
It means
2020.
I want to get the
Area.
area, so I have to multiply point
By 0.2.
this 0.2 times 0.2.
Yep.
Oh,
So it's 600.
yeah. I just use 1.2.
Okay, 600 Newton meters.
Yeah, it's IVA. I thought it's IVL.
No. I ban, not I blend.
So this this name is torque.
You did this in semester 1. I'll show you the page. Page 30. Page 30.
What?
Page 30, have a look.
This one.
Yeah,
No.
this is
What?
where we...
No.
Oh, I missed this class. I think.
Did you?
Oh no! Oh no! I know
Okay.
this.
Torque, turning force, moment. We did these words in this lesson. Torque, turning force, moment. It's all the same.
Okay.
Yeah?
Okay.
A coil, I'll draw this one. A coil is wrapped around an iron rod, radius 5, 100 times. So what you've got is, this is radius 5 centimeters. It's a piece of iron. And you have this wrapped around it. 100 times. Okay? And it's the flux density through the iron is, yeah. So you have a flux through here of 2 Tesla.
This is B.
That's the B.
MBA.
Okay, so I have two parts. One, what's the func linkage, the MBA, and then if there's the angle is 10 degrees, what is it?
MBA cosine.
Yeah, I can calculate.
Plus, okay. Bn is 100. A is, what's A?
You have to calculate it.
Okay. It's
First one is
Decimal. Decimal.
decimal.
1.57.
5, 7.
Now what's the unit?
MBA.
What?
Just the first one's answer.
Yeah, but no, in the exam, you have to give the answer like this. Look.
Oh, yeah.
What's the unit?
It's what?
Half meters.
Well, what's the B?
T.
Tesla. And the A?
Uh,
Meter squared.
Wow.
So you could say it's Tesla meter squared. But also, remember this is the same as this. So you could also say Weber.
Oh.
Not. Oh, and 10. If it's at 10 degrees. So if instead it's at 10 degrees.
1.546. 1.55.
Not so bad, right? Not so bad. Be strong.
Okay.
Alright, I'll let you try these. Page 126. Do your best.
They will have 16 degree temperature.
That's nice.
Yeah.
Do you think watched the last video?
I think so.
She's missing again today. So Gao, when you come to the next class, you need 2 cappuccinos and 2 pastries now.
No one will see the end of the video.
So I could say anything about Gao and she won't see it.
What do you want to say?
Let me tell you what I really think of Gao.